This video is going to show us how to factorize different types of algebraic expressions. We'll cover single brackets, double brackets, and the difference of two squares. Let's get ready to dive in. In our first example, let's start with a single bracket factorization. This involves finding the highest common factor, and this is the thing you should look for whenever you're factorizing any expression. The highest common factor, or HCF for short, is the largest factor that goes into any of your terms. So let's use the example 6x plus 12. Our first step is to identify the highest common factor. For 6x and for 12, the highest common factor is 6. It goes into both 6x and 12. Then we want to factor out that highest common factor. So what we're going to do is we're going to place the 6 on the outside of a bracket, and then we're going to divide our terms by 6, and that will make the terms that go inside our bracket. So 6x divided by 6 is x, and 12 divided by 6 is 2. So by factoring out our 6, we simplify the expression to 6 bracket x plus 2 close bracket. That's simple, right? You can always check any factorized result by expanding your brackets again. Now we're going to move on to double bracket factorization. This is a method used for quadratic expressions quite often. We're going to look at the example of x squared plus 3x minus 10. And we want to identify each of those terms in an order where we want to find the multiplier of just a singular x, and we're going to call that b, and we're going to find a constant number, and we call that c. So for our example, our b value, if you like, is 3, and our c value is negative 10. So our first step is to have a look at the constant number, which is the negative 10, and we want to find two pairs of factors that multiply to make negative 10, that also add up to make the multiplier of x, or often known as the coefficient of x, which is 3. So if we list out all of our pairs, you can see that the correct pair that gives us the answer we want to is negative 2 and 5. They multiply to make negative 10, but add to make 3. Fantastic. Next, we want to write the expression in the factored form. So as you know, we started with x squared plus 3x minus 10. And then our first bracket, we want to put in one of those factors, so we ended up with negative 2, so we'll put that one in the first one. The second bracket, we have x, and then our second expression was plus 5. Your brackets, they don't mind, it doesn't matter which way round you put them. It does obviously just matter which one is positive and which one is negative. So just double check your factored pairs. And that's it. You've expressed your quadratic expression in a factorized form. In our last example, we're going to discuss the occurrences of what we call the difference of two squares. Okay, so we have to be able to recognize the difference of two squares. Don't forget, look at your expression, have a look to see if there are any common factors first of all, and then have a look to see if you've got a pattern of the difference of two squares. And that's why you've got a perfect square number, subtract another perfect square number. So we can apply the formula, that is, if we called the first expression a and the second b, that if you had a squared minus b squared, so this difference of two squares, then that will factorize, become a plus b in your first bracket and a minus b in your second bracket. So we're going to express our example of 4x squared minus 25. We're going to square root our terms, so we'll get the square root of 4x squared become 2x, and square root of 25 become 5. So we'll have first bracket 2x plus 5, second bracket 2x minus 5. And that's it. We've used our formula to find the difference of two squares.